So my name's Brent Schroeder. I head the office as CTO with SUSE. I want to talk a little bit about how security is changing, or how you need to think about the changing world of security as people adopt cloud native and containers. So I'll dive into that. I'll try to get off to a quick start here. And actually, it's a great point, back to Carrie's point. The traditional enterprise was really locked down behind data centers, and there were far fewer ways in and far fewer connections between environments and between systems. And as cloud emerged, that started to open up and more access to your systems, and not all data was on-prem. And now it's really evolving into this cloud native enterprise and a distributed enterprise where there's data centers, there's clouds, there's edge environments, all interconnected, all providing an access point or a risk point for companies. And so really needing to understand, how is the infrastructure and application world evolving? What new threats does that open up, and then how do you protect yourself from that? There's still the perimeter defenses that are necessary. The networks still exist, data centers still exist, and so companies need to protect themselves from that. A couple of recent examples from Google and Microsoft. But there's a whole set of new vulnerabilities that are coming up. Ransomware, we were just talking about, and a couple of examples, even going back to D's. The GPUs, cycle stealing, and the cryptocurrency supply chain. And do you know where, is there issues being injected upstream from software that you're getting? And then just latent issues that might create vulnerabilities throughout your ecosystem. And so how do you protect yourself? So let's start a little bit with just kind of the cloud native security challenges. And what are those emerging challenges? First, it's really about the dynamic infrastructure. It used to be fairly static. Build a data center, install an application, and then that changes at a fairly slow rate. Now, infrastructure changes, applications change, the desire to change, almost on a daily basis. What can I do from a CI/CD standpoint for continuously delivering new capabilities? And infrastructure evolution to better meet customer needs, and how do you respond and protect yourself against that dynamic nature? Second is the security tools. What you've used in the past and how you've protected yourself against that doesn't necessarily always apply or fully apply to a cloud native environment. A great example of this is in the communication between containers in a cloud native environment. It has a communication network that is not visible on the traditional network. So traditional firewalls cannot see that. You need an environment that's got a cloud native firewall designed so that it can protect and see in the insights and what's happening in that environment. Second is that the environment is evolving very quickly. Technology is changing quickly. And one of the number one issues cited among CIOs isn't necessarily the technology itself, but having the appropriate and sufficient people and skills on your staff to be able to address that. Do people have experience in cloud native, in some of the technologies that are being deployed, and therefore insight into the vulnerabilities and the types of security that needs to be put in place? And then finally, automation requirements. These environments are too dynamic, move too quickly, and have too many moving parts for people to manage the security in a manual process. So you need as much automation put in place as possible, and you need the technology and tools to help with that automation. So to address this, there's not a single approach that solves it all. You really need a layered security methodology, meaning addressing the different aspects of security that come in these complex environments. This is often referred to as defense in depth. And defense in depth looks very complex. There's a lot of moving parts. But what I want to do is distill it down into some of the fundamental building blocks and the principles behind those, so you can kind of look at what needs to be accomplished. First is in this rapid agile delivery environment that I mentioned, CI/CD and continuous delivery. You need to be able to protect yourself from the pipeline to production. And that pipeline can be third parties, it can be your own internal development teams. Is security baked into the system as far back as possible? When the first line of code is submitted to a repository, when third-party applications are brought into your repository, are you able to monitor that supply chain and check that code as it's brought in, as it's run through QA, and help prevent it there? And then, as you get known vulnerabilities and they're running into the production environment, can you see those and mitigate against those? So all the way through the supply chain, checking for the known vulnerabilities. As the question that came up, we've seen a defect or a vulnerability in the system. Should it be patched? If it's applicable, absolutely, because that is the number one vulnerability space or breach space. And then finally, the policy and regulations. Can you enforce policy throughout the system and monitor for policy compliance? Systems drift. Sometimes people go in and make manual changes due to a bug in software, want to get it fixed, get a system back up and running. So they log into a system, make a manual adjustment, and that may take a system out of compliance. Can you tell that system went out of compliance? Can you automate the remediation to bring that system back in compliance? Can you monitor your compliance against regulation, particularly for those in highly regulated environments? So that's really about the pipeline to production compliance. And can you do that as a single solution integrated from beginning to end? Second, and it comes to this, the dealing with the legacy aspects and some of the tools, you really need to modernize the runtime protection. Two key aspects of this is admission controls. Can you check your environment and have gates at launch time, at deployment time of applications, to check those applications one last time for compliance to any policy or any last minute vulnerability tests, and then apply a policy to that, whether that application gets launched or not. That's what admission controls are all about. And then I mentioned the container firewall already. You need to have a container firewall in place in a cloud native environment, and the ability to do real-time inspection with that firewall, and ideally deep packet inspection on any communication between containers. So that's the first parts of that are about protecting yourself against the known. The challenge is that many of the threats out there that arise are day zero attacks or day zero threats. And that's a threat that is discovered, such as Log4j, where code may have been in production for days, months, years, and a new vulnerability is discovered in that environment, and it's in production. And how do you protect yourself against that? And that's really what shifting from a implicit trust model to a zero trust model is all about, in that you trust nothing out of the ordinary. And so you want to learn what is normal, what is the acceptable behavior of an environment, of the application, communication between different containers or different systems in an ecosystem, and then disallow absolutely everything else. And that's how you can protect yourself against these 0 days attacks. Log4j, for example, in our 0 day solution, if you had Log4j in a production environment, the most common exploit for moving data out of your environment, our solution, New Vector, would have prevented that exploit from working, and therefore kept your production systems, operational systems, to be able to be up and running and protected against from losing data. And then finally, automation. As I've already mentioned, these systems are too complex, too big to manage in a manual process. A couple of the key aspects to an automation environment, first is behavioral learning. Can you monitor that environment and understand what is the traditional behavior, what is the normal expected behavior of an environment, and then capture that, and then use that as the template for what's allowed in an environment. And then second, policy as code. You can get policy generated as code from the behavioral learning, and then put that code into action in your environment and manage that code just as you would manage any other source code in an environment, keeping that up to date, making sure that it's deployed when updates occur in an environment to ensure that you've got a fully protected environment. So that's a very fast tour of some of the layered methodology that needs to be applied. And what we're doing at SUSE is looking at how do we help simplify this defense in depth methodology. SUSE New Vector looks at each of these particular areas and has an integrated solution in the vulnerability and compliance management, from pipeline to production, from build scanning, registry scanning, and then continually monitoring environment against your policies and benchmarks to ensure that you're as compliant as possible, and then runtime scanning to identify things that might occur in your production environment. I talked about admission controls. We put admission controls in place so that you can apply policy and test against policy when things are deployed. And then a zero trust solution that uses behavioral learning to understand what is normal. And then once put into production, you can put that in a full lockdown, and then anything that occurs outside of that learned behavior will be blocked. You'll be alerted on it and then can take appropriate action, determine if it's a new acceptable behavior and make the adjustments, or if that you've got some type of a breach or attack going on that needs immediate reaction. And if I put this in context of the cloud, and we're a close partner with Amazon. And if you look at New Vector in an EKS environment, there is this shared responsibility model. Ron had mentioned that, where Amazon is taking care of ensuring the security of the AWS ecosystem and has a rich set of products in that space to protect that. But you as the customer of that environment, or the operations team of that environment, are responsible for your environment, for the customer data, for the applications, for the operating system that runs in that environment, and your responsibility responsible for protecting that. And we've designed New Vector to be as broadly supportive of heterogeneous environments as possible. And we're can support EKS environment running on Amazon. We can also reach out and support on-prem container environments or a multi-cloud container environment. So it's not tied to any specific implementation. If it's Kubernetes compliant, we will likely support that environment. So quick summary, make sure that you've got a defense in depth strategy around cloud native. Protecting from pipeline to production, where the developers are working, and also your operation environment, that you're using modern runtime protections, and then trust no one. And then you need to fully automate across that environment. So with that, I'll wrap that up. And if there's any questions, I'd be glad to take them either in the chat, or if we got time for real time.